Good question. The reason I skipped 9.1 is because it works better with chapter 10.
Right.
I honestly don't know why they put 9.1 in chapter 9 and not in chapter 10.
Because it was 9.1, not 10.1.
So nice. So
Do you know the guy that got the girls package and the girl that got the guys package? They swapped.
I would have never swapped. I would have kept that
I would've
Xbox.
kept the Xbox.
Right?
She already got
I
an
don't
Xbox
like
for
Xbox,
Christmas.
But I was like, I would like that, but I already have an
It's
Xbox,
like the
so it like wouldn't
Black
matter.
Mirror.
But
It's
still,
like
it's
Everything is for the Xbox. Just keep the Xbox.
right?
I forgot about
So like, I don't
that.
care about food. I want
That was
food.
awesome.
Exactly.
Like,
Like,
I've had
the
those.
hot wings, like, I wasn't really gonna use those, but.
I thought it was really
Xbox.
funny. It
I
reminded me
love-
of the guy last
love
year that got
playing
the tanning
Xbox.
package. It
So
was like
fun.
totally black.
I was like, yes.
Well,
I was so happy if I got that.
Sorry to whoever's listening to this video.
Oh.
Okay, so this is L'Hôpital's rule. I'm pretty sure L'Hôpital is French. And that's why we say it L'Hôpital
Why
instead
is
of.
it not Little Hospital?
I know.
It does look like hospital, even though there's not an S in the middle. But you really do want to say hospital.
I want to say hospitalers.
So our goal is to solve limits that have a certain form. We had a lot of different limits we could solve already, but most of the time we could just plug it in, solve. Sometimes we could maybe factor and get rid of the zeros. What if there's no way to get rid of the 0 over 0 or infinity over infinity? So L'Hôpital's rule states that the limit as x approaches, I think infinity. I should have maybe written this down. A.
I know. I forgot how I did.
Of f of x over g of x is equal to that same limit with the derivatives instead of the functions. The limit as x approaches a of f prime of x over g prime of x. And you may be asking, how can that be true?
Wait,
I want
is it-
proof.
Wrote it wrong. Is it G of X or G prime?
Thank you.
Oh.
So the proof of this one isn't actually that hard. But we do have to think back to the good old days of derivatives. And we have to think back to the actual definition of a derivative. A derivative is a limit of differences, where integrals is the sum of, oh crap, how do you say it? Limit, or no? The quotient of differences, and integrals is the sum of multiplications. But we have to think back to the old school formula, and actually we did, yeah, x approaches a is what we want. So we are starting on the opposite side. We're starting with the f prime of x, g prime of x, and we're going to prove it's the same as this left side. So we had some old school definitions for derivatives. Derivatives are really the limit as x approaches a of f of x minus f of a all over x minus a. We also had the h, the limit as h approaches 0 of f of x plus h minus f of x all over h. I'm impressed to have those memorized still. So there were different ways, but this was how we actually got the definition of a derivative in the first place. We took the limit of a slope. So what would the bottom be?
The same thing, but with G of X and G of A.
Yep.
So this is all just a giant fraction.
Yep. So now, this L'Hôpital's rule only works in very specific situations. It does not work all the time. So one of those specific situations that we are talking about is if when we plug in A, we get 0. So we know, sorry, I'm going to scroll all the way back to we know it works for the form 0 over 0 and infinity over infinity. The easiest proof to show is when it's 0 over 0. So we know this original limit, we would plug in A and we'd have f of A over g of A is 0 over 0, right? That's the only specific form we're proving right now. So if we know f of A is 0 and g of A is 0, what can we simplify in our fraction? Because we are assuming, that's one of our assumptions, is that f of A is 0 and g of A is 0. Yeah, so you can just take out f of A and g of A. They are 0. You know this, and this is 0. Well now, when we are dividing two big fractions, what is that really? What can we do to simplify the fraction part of this? Okay, instead of dividing the two fractions, it's multiply. So we'd have limit as x approaches a of f of x over x minus a times, and since they both have the same limit, we can combine them together. Limits, when we learned the properties of limits, multiplication is one of the things we could split the limit for. So times, and then we have to flip the bottom fraction, x minus a over g of x. So, what will magically happen? The x minus a's will cancel. Okay. So now we know f prime of a over g prime of a is the same thing as the limit as x approaches a of f of x over g of x if f of a is 0 and g of a is 0. That's all we proved it for. And then I'm just going to tell you the limit one or the infinity one works as well because I don't know how to prove that one.
What?
So if f of a is 0, not f of x, f of a, sorry. And g of a is 0. Or f of a is infinity and g of a is infinity. That's the only time L'Hopital's rule works. So it won't help us with every single limit we do, but it will help us add quite a few more limits we can work with. So we do need to make a note card for this.
Is there any kind of limit that we cannot take now?
I don't know.
That's twice.
With using this, we should be able to use it.
Okay, here's our first example. So L'Hopital's rule only works in those certain situations, so we must check that it applies. So first, we want to plug in 0 and see what happens. We want to try and take the limit like we would normally. So sine 0 over 0.
Doesn't work. It's divided by 0.
But what's sine 0?
0.
0. So 0 over 0. So no, I can't take the limit by just plugging it in. But I got 0 over 0. That makes me happy. Because that means I can actually use L'Hopital's rule.
I like this one.
So, because I came out 0 over 0, now I can take the derivative of each piece. Derivative of sine, cosine, derivative of x, 1. So now we try and take the derivative like we would normally again. So what do I do to take the derivative of something like this?
But it's divided by one, so it's just the cosine.
Yeah. We don't really need to worry about the divide by one, because cosine x divided by one is just cosine x. So how would I take the derivative of something like this? To think back a long time ago. We can't use L'Hopital's rule unless we get 0 over 0. How do we take limits? It's our most basic way to take a limit. Plug in the x value. Limits are the y value unless you can't actually reach a y value, then it's what you're approaching. So we plug in 0. Can I actually find cosine of 0? Yes, I don't have any issues, I'm not dividing by 0 anymore. The whole point of doing L'Hopital's rule is now I have something I can plug this in, and I'm not dividing by 0 anymore. So the limit of sine x over x is 1. So again, L'Hopital's rule, the biggest mistake is just taking derivative after derivative without checking if you can actually do L'Hopital's rule. Sometimes L'Hopital's rule will not apply.
So, after you take the derivative, like, when you put cosine x over 1, you have to take the derivative again, right?
No,
Or you don't?
you do not. You can, if I took the derivative, let's say I had, this is a tough one.
I
I'm
don't
gonna
know,
take
I
the
confuse
derivative
myself
of
with that.
It's possible to get a second time where you get 0 over 0 or infinity over infinity, and then you'd have to derive again.
Oh.
Um,
I don't know, I got confused there. It's been
I
a
think
long
we
day.
will see one come up like that later on. Just can't make one up off the top of my head. Okay, so let's look at another one. So again, first we must check that L'Hopital's rule applies. We must check that. It's an alien smiley face. It's feeling random. Why not?
This video's gonna be messed up on YouTube.
I bet you won't
Probably.
into that smiley face.
I haven't yet, but now I have.
It doesn't apply.
Okay, so Emma says it doesn't apply. Why do you think she would say this?
Because it's square root of 1
1
over 0.
over 0.
Okay, if we plug in 0, we get 1 plus 0 over 0, which is square root of 1 over 0.
Oh, it's 1 over 0.
1 over 0.
That doesn't work.
Alien sad face.
Oh.
It didn't apply.
It's actually a
So,
rainbow with 3 gold coins over it.
and we are dividing by 0, so I can't just, right now, I have no way to solve this limit.
Is there a way to solve this limit?
I think this is something we'd have to look at graphically and numerically. We'd have to look at the picture and see if it's probably going to infinity or to negative infinity. We'd need to look at the picture to see which one that is. Well, okay, let's see. So this one we would say the limit does not exist. If I try and put in negative numbers, -1 would work, but -2 will not. -2, we'd have imaginaries. Guess if we had -1/2, no, I'd give you a picture. I think a picture would just be the best option. Yes.
What happens if you plug an equation in your calculator and it says false?
That means there's no solution.
Because 1 or what?
Oh, I was just working on the
It's
test and I
telling
plugged
you.
in something and I'm like, I can do this, and it said false. It basically ruined my test.
Okay,
Because of that one fault, my whole self-esteem plummeted.
It
I could
did,
not
it plummeted
remember how
for
to do
about an hour and a
anything.
half.
And I failed because
No,
of
I
that
need lots
one
of sugar.
failure.
okay,
It was a big failure.
And now I'm working in McDonald's
so what
for the
must we
rest of my
check
life.
first?
'Cause I'm doing
Locals.
If Josh
To
is here.
see if
it. To
If
see
not,
if Josh is here.
L'Hopital's rule actually applies. To see if when we plug in 0, we get 0 over 0, or if we got infinity over infinity. So I want you guys to plug it in first and see if L'Hopital's rule applies.
My calculator said false.
There's smiley face next to it.
So if it works, what do we
I
do
don't know, that
next?
came out weird.
Draw a smiley face.
Besides that, after drawing a smiley
And
face,
take the derivative.
take the derivative. So I'm gonna have you guys work on this independently. Try on your own to see if you can figure out what the limit is. Set of derivatives there is now.
It's 0 over 0.
Okay. When we take our derivatives, you guys should have gotten 1/2 x plus 1 or 1 plus x. I switched the order.
Yeah, because then it's negative
Times 1. Minus 1/2 because that goes to 0. All over 2x. And what does happen when we plug in 0?
It's 0 over 0.
0 over 0 again.
Shouldn't you move the negative 1/2 to the bottom?
Wait.
Are you just
Um,
gonna leave it on
Just
top?
do the body and
what do you mean? This piece?
over.
Well, since it's to negative 1/2, it would move to the bottom.
Except,
Oh boy.
since it has another piece minusing, it would actually move it just to its own fraction on the bottom. Which wouldn't help us much, so I'm gonna leave it.
Huh.
So if we do plug in 0 again, we get 1/2 minus 1/2, which is 0 over 0.
Yeah.
So we need to do L'Hopital's rule again. So we just have to take the derivative a second time. So we get limit as x approaches 0. Negative 1/2 times 1/2 is negative 1/4. X plus 1, so the negative 3/2 times 1. And why did I just leave off the other part?
Because it's
Derivative of 1/2 is 0. And derivative of 2x is 2.
Ah, but 2 can't go to 0, so we can't take it a third time.
So we cannot take the derivative again, but we can still plug in 0 and get our final answer. Negative 1/4, 0 plus 1 to the negative 3/2, all over 2. 0 plus 1 is 1. 1 to the anything is 1. So we get negative 1/4 divided by 2, which is negative 1/8. Now again, L'Hopital's rule will also work if it ends up being infinity over infinity. Does everyone have this down before I move to the next page? So try this problem. So what happens when we plug in pi over 2?
It comes out as infinity over infinity.
Is that
Comes out textbooks. Did you
infinity over infinity?
Did you ever put on the recording?
Yes. So then we take the derivative. We still have limit as x approaches pi over 2. We get derivative of secant is
Tangent x tangent.
derivative of 1, 0, and derivative of tangent.
Secant squared of x.
And it's in
So once we do that derivative, we can do any simplifying we need to at this point. So we can,
Kill the secant.
yes. It's a little extreme, but yes. So now we're going to do some trig simplification. What did we say we should do for our trig simplification?
Sine over cosine over 1 over
cosine.
cosine.
So sine over cosine, and then over 1 over cosine is the same as times cosine.
Over 1.
So then we can just plug in pi over 2 to get our final answer. Sine of pi over 2
It's the only one that's not dead.
is
1.
1. Now, L'Hopital's rule has some forms where we can actually rearrange things and get it to be 0 over 0 or infinity over infinity. But I feel like we're not going to have enough time to do that thoroughly. So we're going to do some of the basic forms for the rest of the time. We're going to do a homework assignment. So you might have time to finish the homework assignment, and then we'll finish L'Hopital's rule on Monday. So, if you get any other form but infinity over infinity or 0 over 0 right now, then you'll have to say, I can't do this. Later on, when we get a form, like there's 1 to infinity that we can rearrange, or infinity minus infinity that we can rearrange, then we'll learn that way how to rearrange them next time. Would have been helpful if I wrote the page number down.
You don't have to write a page number, just give us an example.
Or 54.
Just give us some numbers, we'll put it on a random page,
And
preferably in the,
That's right.
1 through 8, 33, 35, and 41. And the instructions on 1 through 8, one of them says to look at the graph. I just want you to use L'Hopital's rule. The second, use the stronger form of L'Hopital's rule. That just means you're going to have to take the derivative more than once. We only have like 11 problems. Come on.
No, I'm
Why
excited.
yes? Thanks, Lily.
I have 11 problems. You have 11 problems in
You know,
calculus.
you're kind of just like, whatever, you guys.
11 problems.